Super job. Right, let's get this going and start some screen sharing. Here we go. Cool. So this afternoon's presentation is for the first hour. We're going to be going through LED panels and controllers, just explaining the differences between some of them, showing you different types of panels, different types of controllers, and explaining when you want to use what and why, and then going through some questions as we wrap up the end of the first hour. And then in the second hour, we're going to go through building a small Tune 2 sign using a color light card, FPP and Xlights. And hopefully it's going to be a bit of a rush, but hopefully we'll get the whole thing assembled and working just about in the hour. So we'll give it a go. So fingers crossed. Moving on then, let's get this slide moving. This is pretty much what I've just done. So what's an LED panel? What makes an LED panel? We're going to go through some different sizes, P numbers, indoor versus outdoor. What is a controller? And we look at color lights, pi hats, BBB capes, etc. And then we're going to do the build. So a bit about myself. I'm Greg Mackery from Hickling in Norfolk, England. So if you look at England, there's a sticky out bit on the right-hand side, up in the top corner of that, at the far edge of nowhere. The only thing beyond me is the sea and then Holland. I've had my own show for about 6 years now. I got into Raspberry Pis very early. I ordered on day one when they were first released back 9 years ago now. So yeah, lots of Pis doing all sorts of different jobs around the house, DHCP, DNS, running solar, looking at solar panel monitoring, all sorts of things. And I had one to spare, and I thought I've got to be able to do some blinky flashy with this. Of course, I didn't say blinky flashy at the time because I don't think that term had been invented then, but anyway. So yeah, got some pixels and off we went, and I haven't looked back. Got some going. Then I found on YouTube the dreaded Matt Johnson video from 2014, I think it was, of his dubstep house. So I departed from the Pi briefly, wandered into Vixen and Arduinos and other things, but wasn't happy with that. And so it turned out neither was Matt, and we've all ended up back in Xlights, using FPP and all the regular Xlights and whatnot. Last year, I wanted to move into panels. Very beginning of last year, I decided panels was the thing to do, and there was nobody in the UK doing it. I couldn't buy them in the UK, apart from one vendor who wanted stupid money. So I set about doing a group buy. That went down very well. We got through several hundred panels on that group buy, and it's turned into a full-time job. One thing led to another, and now I've got Panels Are Us as a full-time job, selling panels, accessories, etc. to the UK, Europe, and even to the States occasionally. Family-wise, yeah, happily married with 2 young children. I did have hair, and it's receding rapidly, with one 6-year-old and one 3-year-old, and what's left is going grey. So really good. And last but not least, living out on the edge of nowhere, the internet here isn't great. We get 30 meg-ish on a landline, but when we're trying to do panel videos and things, it's not enough. So recently managed to get Starlink set up on the roof of the house, and now we can upload and download at sensible speeds. We're getting up to 400 meg via satellite, so all very good. Sadly, it's not the most reliable at the moment. It tends to hiccup every so often. So we're back on the landline for this presentation, and fingers crossed it sticks with us. Right, enough of PowerPoint. I hate PowerPoint with a passion, so I am going to stop screen sharing. And you can look at my ugly mug. Haha, right. So we're going to be doing most of this now on video. The only two slides I've got left say any questions and thanks for watching. And that's it for the next hour and 3/4. So we're on video, and that's the easiest way to be. Let's just get it out, get it in front of you and show you what you're doing. So with that, let's begin with panels. Now I'm going to swap cameras. I've got one looking straight down at my desk as well as this one that's facing you. So then we can show you what we're talking about. And there we go. Perfect. Technology works. So what is a panel? I mean, we've heard of matrices, lots of lights, probably 2 inches apart or 50 mil in Europe. What makes a panel different? Well, a panel is basically exactly that. It's a group of pixels. Thank you for spotlighting. It's a group of pixels in a plastic frame, all ready to go. Now they come in all sorts of different shapes and sizes. This one I bought online. I didn't look at the spec properly. I just looked at the pixel count, which said 32 by 16. And I thought that's a P10 and that'll do me perfectly. What I didn't realize is the how important the P number is. Now the P number is the number of millimeters between pixels. So this is actually a P6, which means there's 6 millimeters between each pixel horizontally and vertically. So your P6, and then you can go down. So this one is a P2. So you can hardly see the pixels on this one. This is a P2. So lots and lots of pixels on there. And of course, you can go up. So this funny looking thing is a P10. Now you'll be looking at it and thinking, but it's red. It is red. Again, this is the sort of thing you need to watch out for. So this one is a single color P10. It is literally 32 by 16 in red LEDs. So there's a few of the differences that you're starting to look for. So we've got sizes, we've got densities, and you can even get different shapes. So this one is a square one. Most of them are rectangular. Now, the only ones that we're really interested in for our hobby are P5s and P10s. And it's actually none of these. So I can take all of these away and replace them with, let me put that one there. There we go. This one is a P5, 32 pixels high by 64 across. This one's an indoor panel. And P10s. So this one is a P10, so 16 high and 32 across. Now these are the two most commonly used flavors in our lighting community. Dependent on the look that you want to give, whether you want the display to look slightly pixelated if your audience is up close, or if your panels are far away from the audience. For instance, if they're 50 foot or so away, particularly in the US, Canada, where you've got massive front yards, then density might not be so important. But particularly in Europe, we don't generally have very big front yards. And so density is more important to us to get the quality of image. So your P5 here has 2048 pixels in this one panel, and your P10 has 512. So things to bear in mind is the density. Uh, if you're working close up, then you probably want the density, unless you want your show to look old school pixelated, in which case P10 might be the route for you. Something else to bear in mind is that the P5 has 4 times the number of pixels of a P10. So the P10's got 512, the P5 2048. And that's just one panel. As you get bigger and bigger, then of course the number of pixels increases dramatically. So if you're running like a 6x6, for example, that's 36 panels, 36 times 2000, you're up to 72 and a bit thousand pixels. Now that can take quite a lot of rendering in Xlights, and it also results in large FSEQ files, which then need to go out across the network for the show to run. And that is why we always tend to recommend that you run either your BBB or your Pi as a remote. And that way you can upload the big FSEQ files for the matrix beforehand. So you get that up and done. Speed doesn't matter at that point. But once the file's up there, then you can run the matrix in remote mode, and it's just got to deal with the file locally, so that it doesn't matter. It's not going to introduce lots of traffic on the network. Okay, so these are both what we call indoor panels. And what do we mean by indoor panels? Well, it means that there is no weather protection on these whatsoever. You cannot get them wet. Otherwise, they will go kaboom, and you get the lovely electric smoke. On the back, no protection at all. We've got bare electrics. On the front, again, no protection. If water gets in there, then there's going to be issues. Doesn't mean that these aren't used extensively by our community. They are, because they actually perform, in my mind, a little bit better than the outdoor panels for the use that we want, i.e. nighttime. Now, at night, these can run at full power quite happily, and we're not going to blind anybody. They're going to be bright, or reasonably bright. And we've got the full range of the color spectrum, the full gamut of colors available to us. The outdoor panels use a lot more power. They're a lot brighter, which means for use in nighttime, we've got to cut back on the brightness that they're using. We've got to reduce the power levels and therefore reduce the brightness. And that in turn limits the color spectrum that we can use, because each of these pixels is one of 16,000 odd colors, 16 million colors. If you reduce it by 50%, then you've cut down the number of color variations that are effectively available to you. So indoor panels actually work, give you better color representation at night than the outdoor ones. But you do have to make an enclosure for them. Now, I know there is an enclosure build party. Well, I'm not sure it's a party, but there is an enclosure build demo right after I've finished later on. So you can move on to that and see how that goes together. If you don't want to make your own one, I know Ken sells completed enclosures in the US, and I do them here too. So your options are up to you. You can either make your own, or you can spend some money and buy one. I will talk about outdoor panels as well. So this one is an outdoor P5. These, as you can see, these LEDs are a lot bigger than the ones on the indoor P5, and it's a lot more powerful. These indoor P5 matrix, when they're running at full brightness, 100% white, they will draw about 2.5 amps at 5 volts per panel. So they do like a bit of juice. These ones can draw up to about 7 amps on 100% brightness. So if you just use basic maths, it means they're going to be about 3 times brighter. And it certainly is obvious. You can see these in daylight with the sun on them. You can still see them clearly. you can't see anything on these in daylight with the sun on them, unless it's a very gloomy day. On the back of these, there is a protection. I should have brought one, but I didn't. There is a rubber membrane that fits around these. So you can seal them flat onto a solid surface. Well, that's the idea, onto a solid surface, and then that gives you protection. You can cut a hole in the solid surface then for access to your data in, data out, and power. But the front then is water resistant. You can spray a hose on it and it's fine. The back is protected by the rubber gasket, and you can stick it outside. So that gives you an idea of indoor versus outdoor. So let's look at the connectivity on the panels. If I tip this one over. So on the back of all the panels, and they're all pretty much the same, you have three connections. You have a data in, a data out, and power. Now, all of the panels run on 5 volts. I hate 5 volts when it comes to pixels because I like more power, but all panels are 5 volts. So you power in, and then you've got data in, data out. Now, the idea of data in, data out, if I move this one over here and grab another one. The idea is that we can lay them side by side and then just daisy chain the data connections. So with your pixels, you normally use either a 3-wire WS2811 style signal or a 4-wire WS2801 style signal. The panels, they use a 16-wire IDC cable. So that's an insulation displacement connector, 16 pins, and they just simply clip in like so. So it's called a hub 75 connector, and you simply join your panels up, daisy chained in rows like that. Nice and simple. Fix them to whatever you're going to fix them to, and away you go. Power wise, let me just reach over here. Oh, power wise, you get power cables such as these. You normally get them like this, a Y power cable that will run 2 panels simultaneously. So they're just about long enough. There's a bit of a stretch, but they are just about long enough to stretch like that. Personally, I hate doing that. So if I can possibly do it, I'll run them one above the other. So this then needs to be connected back to your 5-volt power supply. Now, I normally use a rated, a known branded power supply, such as a Meanwell. These panels are, I won't say they're susceptible to, but they don't like noise fluctuations on the power line, and they can get grumpy fairly quickly if you feed them too many volts or something like that. If you get some major spikes or transients come through, then you can upset panels fairly quickly. So I will always use a branded power supply for them, just to make sure. I have had panels returned to me where they have let the magic smoke out en masse, and I've had to explain that we can't warrant that because they're all tested before they go out. If you put a cheap and nasty power supply on there to save yourself $5, then don't come crying, I'm afraid. So always look for a decent power supply. Okay, now when you buy your panels from wherever you get your panels from, you will normally get one power cable for every 2 panels and 1 little data cable for every panel. So you don't have to worry about buying those separately. They should come with the panels already. And if you're buying outdoor panels, you'll get a rubber gasket as well to go with. Now, these panels are originally designed to mount to a steel or a ferrous backplate with magnets. Now, I have just put my tub somewhere, bear with me. Here we go. So they come with these magnets. You get 4 magnets for every indoor panel. The outdoor panels don't normally come with them. These then simply screw in to corners like so, and then you can stick it on whatever it is you want to stick it onto. And it makes it nice and easy then to remove should you wish to. Now, one of the more common methods of mounting these days is not to use these at all, but is to use 3D printed mounts. He says he should be organized, but he's not. Is to get some 3D printed mounts that you can simply stick onto the things and join them together. Hang on. Oh, Xlights schemes and all of that. Here we go. So this is an example of some mounts here. So these literally just clip on onto the panels like that, and then some M3 screws will simply go in and hold the whole thing together. Now, they're fine if you're doing something indoors or you're making your own enclosure or something, then these little brackets will work beautifully. There's lots of these on Thingiverse, or you can roll your own or buy the STLs if you want them. Doug Reel does them, I think I do them, etc. So that's another method of mounting. So the indoor panels, as I say, are all M3 threaded holes in the corners. The outdoor panels are larger. These are M4s on these, as opposed to M3s on there. And you don't want them to be too long either. The ones that I ship out with my mounts, the mounts are 5mm thick, and the little bolts are 10mm. So that gives about 5mm going into the back of the panel. You don't want to go any deeper than that, otherwise you risk destroying the panel. Again, I had a customer buy some STLs and they came back to me and said, I've killed my panels. Well, how did you manage that? I said, well, I got these 18mm M3 bolts and I stuffed them all the way in and then the panel popped. Yeah, you just can't make it up. They've gone straight through and through the panel. So just be careful. I know all the stuff that Ken does. He ships little bolts with his. So if in doubt, ask. But don't be daft. Okay, so we've done data in, coming in from a controller. We've done power, data out. We've done all the various, I think we've pretty much wrapped the panels side of things. Any questions on panels before I move on to controllers? Can hub 75 cables be made at home? Yes, absolutely. You can buy 100-meter reels of the stuff and IDC crimps. I use a little vise to make them up. But yes, absolutely, you can make your own. I've tested them up to about 7 meters, 20 foot long, and they seem to be okay. So yeah, all good. No worries. Thank you to my A team for fielding questions by the look of it. I've not been looking at the chat, but I see some of the European A team are on it, which is great. Thank you, guys. All quiet. Fingers crossed. Either everybody's gone to sleep or you're interested. That's good. Okay. Right, so let's move on to controllers then. So we have 3 main schools of thought when it comes to controllers. We have the professional solution in the form of the color light card. we have the common um, we have the common domestic diameter one, if you like, in the form of the beagle bone black with an Opta scroller on top. And then we have the smaller one, the Dan Culp Pocket Beagle, as well. Now, the Colour Light card is my preferred card of choice. In my humble opinion, when I viewed sequences side by side, I found that the Colour Light gives better colours, a smoother image with better colours, and it overall just won for me. I found it gave the best looking panel out of the three. I know what I have missed, of course. I'll put those there. We've missed a Raspberry Pi with a hat on it. I knew something was missing. So the Colour Light, in my view, is going to give you the best. Now these have 8 outputs, as you can see, 8 Hub 75 connections that take the other end of your data cable from your panels. They plug straight into there. And you can daisy chain up to 8 panels from each of these ports. So this one Colour Light card will give you up to 64 panels. Now, there has been a little bit of confusion about that in the past, because we've seen people, including myself, saying you don't want to run 64 panels off a Colour Light. They can only do 4 panels wide. Well, that used to be the case-ish. So the P5, the Colour Lights up to version 7, so that's one of these, would run 8 panels wide, but at a reduced refresh rate. So it could run up to 4 panels wide at full speed, and then it would start slowing down a bit as you added extra panels. Now, some doubters would say, well, they couldn't tell the difference, but I knew there was a difference, and so I wanted the best. If you're spending hundreds and hundreds of dollars or pounds on building a matrix that size, why scrimp on $20 for a second Colour Light? However, the problem has now gone away. With the version 8 boards, they are now running up to 8 panels wide at full tilt, at full speed. So these will run 64 panels quite happily. But what happens if you want to run more than that? Well, with the Colour Lights, it's really simple. You just get a piece of network cable, you connect it from Colour Light 1 to Colour Light 2, and then you can have another 64 panels. And you can drive the 2 off the one Raspberry Pi. Now, I need to confirm that the exact numbers on FPP at the moment, because it has changed recently. FPP itself had a limitation of 8 panels high by 12 panels wide, but that still takes you past one Colour Light. So, but you can daisy chain the 2 and to go on. And I have got a video on YouTube. If you look for Panels R Us on YouTube, I've got a video on there where I demonstrate using 3 Colour Lights to build off of one FPP. So these will scale, unlike these. Right, so they're good for the big boys who are doing really big, shiny displays, and the expensive ones. But then for people that are doing something smaller, you probably don't want the complexity of a Raspberry Pi and a Colour Light all in the back of your little North Pole sign. So you want to look at something smaller, like a hat. Now, this one is a Hanson Electronics hat. Alan Hanson's really good at producing these things, and they're available in the UK. And I know Ken has got them in the US as well. I'm sure Wally has something similar, and the other guys. So these sit on top of the Raspberry Pi using the 40-pin I/O connector, which connects straight into the 40-pin I/O on your Raspberry Pi. So it simply sits in there. We can feed the whole thing 5 volts through this terminal block on the end here, and away we go. This Pi anyway has got Wi-Fi on board, so as long as your Wi-Fi is in range of the house, then that's it. You're away. So this is one method I find as a really good little thing for a tune to or something like that. Now, in theory, these can run up to 6 panels wide off each of these connectors for a P5. Figures increase for a P10 because the number of pixels obviously decrease. 6 panels wide, and they'll run quite happily 18 panels. The Pis do struggle a little bit because of the nature of the architecture on board. Every time they get an interrupt for something else to happen, they have to momentarily stop what they're doing, wander off, fix whatever it was that asked for some help, and then come back to displaying the panels. Now, that can be seen occasionally as some jitter, as some noise in the display, which is why I tend to use these for smaller displays, where it's not going to be quite as noticeable if they do have a little think about it. So that one runs up to 18 panels. Now, there are other options. If you're building a North Pole style sign, then you might want pixels. If you're doing a globe on the end, or you want to put some little lights around it, then you could use something like this one here. So again, this is another Hanson board. This is a Pi MFC hat, and it's got an output for a panel. It's also got outputs for pixels. So you can run pixels and panels off the same little board. And if you've been watching Tom Beck George's just in front of us, we've got an output for DMX here as well, so we can stick a moving head on if we want to. And of course, underneath an RTC, a real-time clock battery holder. So this thing could sit on its own, not connected to anything, and just get on with it. Once it's got the time, it can just potter on and do its thing. An OLED display on the top here tells us what's going on, and we've got some inputs for cabling, so we could wire some buttons in as well, so people could press different buttons to make things happen. So again, different options for a Raspberry Pi running panels. So that's those two. So that's your Raspberry Pi. Now this one I've got here is a 3B plus. You can tell it's a 3B plus or later because it's got the big silver Wi-Fi with the Raspberry logo, the Wi-Fi chips all under there. You really want a 3B plus or later, really, if you're playing with panels and pixels on a Pi. The others are okay. Going back a bit, the very first ones only had a 20-pin connector, so they won't fit any of these modern boards. Let's actually, we've got one right here. There we go. There's an original Raspberry Pi. I think it's probably the one I bought on day one. And as you can see, it's only got the tiny little GPIO connector. So that one won't work for us anymore. Besides which, these really haven't got a lot of power to them now compared to the modern ones. This one's a 3B plus, as I said. I've got a Pi 4 here. You can tell the difference right away on the Pi 4. 3B plus has a full-size HDMI connector, whereas the 4 has got two mini HDMIs. I think these ones are mini or micro, I'm not sure which. And so they're easily differentiated. The other difference is the power. So the 3B plus and earlier, we look at the original one as well, we've got a micro USB in for power for 5 volts. The Pi 4s have moved to a USB-C connector. Now the Pi 4s with the extra power also use more power. they're running up to about 3 amps now. So you need to bear in mind when you're factoring in power supplies that your Pi can draw up to 3 amps if it's a Pi 4. If it's a 3B plus, 2.5 amps is plenty. Now, of course, they do also come in different varieties. If you're just running a single panel or a couple of panels, you might want to use a Pi Zero. Really tiny little thing, only slightly more powerful than the original Pi, but it's enough to run a couple of panels. So one of these will set you back about £10. Thing to look for though is the headers. Out of the box, the standard Pi Zero doesn't come with the header pins, so you have to look for a Pi Zero with headers. And you also have to make sure, if you want Wi-Fi, you have to make sure you get a Pi Zero W with Wi-Fi. You probably can't see it on here, but this one is a Wi-Fi one. There's a funny little arrow shape at the bottom there. Let me see if I can get that into the picture. Not really, just about. So that's a Pi Zero W with headers. Just about good enough for a couple of panels or maybe some pixels, but not a lot more. So they're okay. If you don't want networking, you're just going to be or wired networking, you can always get a Pi 3A. Very similar to the 3B, but it hasn't got the big Ethernet jack and it's only got one USB port. So very similar, but smaller. So it might fit into your scenario better than a full-size one. So that's the Pi 3A, and these are the Bs. So B includes the wired Ethernet and A's don't. Right, I think that's covered Raspberry Pis. So then moving on to the main competitor for the Raspberry Pi is the BeagleBone Black. The BBB, which when paired with an octa-scroller, such as this one, I think Dan Culp sells octa-scrollers. This one again is a Hanson board. Away you go. Now the BBB's architecture differs from the Raspberry Pi in that it can handle interrupts and multi-threading better than the Pi. So it can get on with the task of driving panels and not get interrupted if it has something else to do. So it can spool up another thread, do something else in the background and shut it down without interrupting the process that's running the panels. So if you didn't want to go the whole hog and go for a color light, then you could go for an octa-scroller. Now again, we've got 8 outputs. Each of these can drive up to 8 panels. So up to 64 panels off one of these. You can feed it power directly via the hat, or sorry, the cape. For some reason, on a BBB, these are called cape. These add-on boards are called capes, whereas in the Pi world, these ones are called hats. Don't ask me why, they're just so yeah, capes on a BBB, an octa-scroller on a BBB, and away you go. I didn't find that the colors were quite as crisp as a color light card. When running a sequence side by side, it wasn't quite there to my mind, but your mileage may vary, and so they are available. One of the handy things about the BBB is, of course, it's got the micro SD card slot for loading FPP, but it does have onboard memory, unlike the Raspberry Pis. So you can load up your BBB with FPP, and then you can move it from the SD card to its onboard memory. Then you can take the SD card out and it will boot and run from its onboard memory. If you're putting this into somewhere where you might not be able to easily access it, I mean, ideally you really want to be able to get to it, but if you're putting it into a commercial situation or something where you don't want the risk of a micro SD card doing something stupid to itself, then that might be an option for you. So there we go. So there's a BBB. Power is via a mini USB, or it's got a barrel jack, or you can feed it via the pins on the cape. 10100 Ethernet on a BBB. Raspberry Pis, actually, that's something I didn't talk about, was Raspberry Pis and Xlights. The modern Raspberry Pis can drive a Xlight because they have gigabit Ethernet. So if you have a Raspberry Pi with a nice silvery bits in the corner, then it's either a 3B plus or a 4, and it can drive a Xlight. If it's older than that, then this is only 10100 Ethernet, and it can't drive a Xlight. So you need one with gigabit Ethernet to drive a Xlight. Sorry, stepping back. Right, so that's your BBB. And then your last option for the tiddly ones is a pocket beagle, and the little pocket scroller, as shown here in a Dan Culp pocket scroller version. So this one has 6 outputs for panels, and these can drive up to 6 panels each for a total of 36. So these are not particularly common in the UK and Europe, because beagle boards are a lot more expensive, or pocket beagles particularly, are a lot more expensive over here than they seem to be in the States. So I've had these ones in the shop, and nobody's paid any attention to them at all, but they're there. So 6 there, 8 on there. You can run 18 or so off a Pi, and 64 or more from Xlights. Yeah, so all of the where I've been talking about panel numbers, that all relates to P5s. For P10s, you can get more. How many more varies depending on the board. But most people are using P5, so that's the numbers that I tend to quote all the time. So 6x6 for 36 P5s there, 64 P5s 8x8 there, 18 P5s there, and 64 again there. Okay, that pretty much sums that up, I think. Anybody, any questions? Let's have a look. Yes, so how far can you have between a Pi and a Xlight? So the answer is it is Ethernet between your Pi and your Xlight. So up to 100 meters, 305 feet is the Ethernet standard. One thing to note is that the protocol used by the Xlight cards is not standard TCP/IP. So you can't just stick it on your home network, stick the Pi somewhere else, the other end of a router or a switch, and expect it all to work. The protocol, it does chuck nonsense. If you stick this into your home network switch, you will find that your home network grinds to a halt fairly quickly, because it spews out of every port. It's horrible. So you really want to have a direct cable between the Xlight and the Pi. Yeah, no switches, routers, or anything in the path if you can do it. Just a straight bit of Cat5 between the two. Okay, is configuring the Xlight and FPP different from a Pi hat? Yes, we'll go on to that in part 2. We'll talk about that. We've got a Pi here ready to go, so we'll get that up on the screen, and I'll talk you through that in the next session. How far apart from panels be from each other on the same controller? So I've made cables up to 20 feet, about 6 meters, and they've worked fine. So yeah, however far apart you want them, up to about 20 foot. It might be more, but I haven't tested that. Bum, bum, bum. All quiet. Excellent. Roger, I know 3 meters works fine. Yes, that's good. Yep.
Just a quick one, Greg. Did you answer the one about the 8 ports drive and 8 watt P10 or P5?
I did. Yeah. So I was talking P5s all the way through. Thanks, Ted.
Cool.
Yeah, talking P5s all the time there. P10s can do more than that because they have a quarter of the pixels of a P5. So you're probably looking at double the width. Height you're going to struggle with because that's reliant on the number of outputs. So you can still only have 8 outputs on one of these, but you can get twice the width, but you're still stuck on the height because of the physical connectivity. Unless, of course, you do some weird and wonderful daisy chaining, which we can talk about in fact, we can talk about it now briefly. If I move those up there is nothing to stop you. The panels all have arrows on them to indicate which way is supposed to be up. So when you're assembling your matrix, you should normally configure it with all the panels pointing up like that. But it is possible, if you need to have extra height and not width, then you can add a row of panels upside down. So you could do that and then put your data in as normal here. We'll jumper across there. Then we would need to jumper from there to there. And then another one. We've got some longer ones. That's no good. There's one. And then we could jumper there to there. So you could have your data coming in here, across there to here, up to here and back. So you could get a 2x2 running off one port. So that might be good if you're running the little Hanson MFC hat that's only got one port, and you could run a 2x2 panel off it still. So yeah, over to your imagination really. I mean, it is, if you're stacking them one on top of the other, I mean, you could end up with them like so. And then just daisy chain the cable so the data flows in a zigzag all the way up. It's up to your imagination and whatever crazy thing you're trying to build. Okay, is there a trick to determine the proper chip to use in a color light config? The best thing for that, Paul, is speak to your vendor and they should be able to give you what's called an RCBVP file, which is a receiver programming file to set the color light up for your specific panels. You should be able to get those. If not, it's a case of getting a magnifying glass out, looking at these chips and working out what chips you've got, and then setting up the color light accordingly. Is the language specific to the controller over Ethernet? Yeah, so the protocol from coming into the color light card, if you're using a color light, then it's going to be the same color light protocol that's coming out of the Pi going to it, whether you're running either your PC driving the color light card directly or whether your Pi is running the color light card, then so be it. Now, something that is available that I haven't really used is Scott. If you're not into FPP, you don't like FPP, you're an X schedule person and you want to Windows PC running your show, there is a plugin for Xschedule, which allows you to run a color light card directly off the Ethernet port on a PC. I had a quick look at it. It was a bit convoluted to set up. I'm sure once you're used to it, it'll be fine. But you can then run a color light directly off your PC without needing a Raspberry Pi and FPP. Have a look, or if you Google it, I think I Googled or searched the official Xlights group for Scott Hanson and whatnot. What distro board do you use? I used an F8, but the wire gauge was 2 click. Right, yeah, so bear in mind that because each of these panels is pulling on the little ones, they're pulling 2.5 amps each. And at 5 volts, you want a reasonable gauge of cable. I wouldn't use anything much less than, oh, excuse me, probably about 16, 18 gauge. So you want something with a bit of space. Now, for this next, or in the demo, I'm going to be using one of these, which is a Meanwell RS. This one's a Meanwell RSP power supply. In the US, I know you use LRSs, but they're illegal here. So we have to use RSP with extra protection because we're not safe, apparently. You guys can run around with guns and we're not allowed even an LRS power supply. This one is a Hanson Power Distro, PDist-1 Power Distro board that is hanging off the front of this Meanwell. This has got plenty enough ports, and they'll run up to 10 amps each on these ports, so we can connect 4 panels to each of these pairs of outputs. So this is what I tend to use in my smaller builds. There are other Hanson panel power distro boards available, but I haven't got one here to show you. Cool, hopefully that's that one. Cool, right, we've got another 5 minutes of questions or so. Do I fuse each panel? I tend to fuse, I wouldn't fuse each panel because that just seems like overkill to me. I tend to, when I'm using something like this power distro here, this would be fusing 4 panels. So each 4 would be fused. And I think that's a sensible number. You don't want to go too few, but you don't want to go too many. I mean, if you really wanted to, you could, the Y cables as such, you could fuse every pair of panels. And dependent on the power supply, depends on what you need to do. Is there any other software to drive the controller card? So you've got 2 options. For configuration, you've got LED vision, and that can also be used out of the Christmas season. If you want to watch a video or something like that, you can play MP4s in LED vision and output them to your panel. So you might be able to use it in the summer when you're watching a film outside. And you can do other things with LED vision as well. So yeah, you can drive your color light that way in the off season and then bring it into FPP for Christmas time. Other than that, you're looking at Scott Hanson's plugin for Xschedule to run it that way. What version of LED vision? So with the color light version 8, you need to be running version 7 or later of LED vision. Sorry, this one's the 8. Yeah, so you need to be running version 7 or later for the version 8. I tended to use version 5 with the version 7 and earlier color lights. The difference, the only real difference, if you want to go looking at your card and can't tell, it is written on them, version 8, version 7. The the version 8s have got a power plug, the same as the panels. So if you have a spare panel connector, you can drive your Xlight version 8 directly from a panel power cable, whereas the version 7s and earlier didn't. You're definitely relying on the terminal connectors there and there. So version 7.2 is the latest, and yeah, I use version 7.2 for everything now because it seems to be stable. The version 6 has got a bit flaky. The first version 7 had some issues, but 7.2, he says, touching wood, seems to be okay, and that's what we'll be using in a few minutes. Did we ever know get an answer if FPP can handle the big boy Xlights with 16 ports? So there are 16 port Xlights out there. The big daddy to these has got 16 ports, and I didn't. Dom is the answer. I will investigate and come back to you. No problem, Dom. Oh, a glass of juice. There we go. We're not doing too bad then. What is the juice? It's really boring orange juice. It's not exciting. It's not even adult juice because I wanted to be sensible. So we have lost. Oh, we've lost about 4 participants so far. So that's not too bad. So all good. So I hope you're all enjoying the fun of VCS so far. Does LED vision run on Mac? No. I'm allergic to Macintoshes, and no, so is LED vision. No, you need a PC. I'm not even sure. Did Dom will know the answer to this one because he's a yeah, thanks, Ted. Dom is a Mac man. Does LED vision run on a Mac, Dom? It does not. There you go. See, Windows. What do you want a Mac for anyway? Only silly designery people and whatnot use Macintoshes anyway. A proper person has a Windows machine. Boot Windows. Yeah, okay. We like Windows. You can boot camp if you have a previous pre-M1. Well, there you go. If you have a pre-M1 Mac, you can boot camp it. That means absolutely nothing to me. I'm completely Greek on that one. So will you cover enclosures? No, I will not cover enclosures in the second part. But in a third part, which is coming to VCS immediately after I finish, there is an enclosure build. Let me have a quick look. If I drag this over here, there is a panel enclosure build in the Gilbert engineering room right after I finish. So happy days. Is there an interval? I love an interval. Love spending £5. You'll just send me the £5, Dom. Yes, if you want a wee, go and have a wee now. A toilet, a comfort break, toilet break, wee, whatever you want to call it. Go and have it now, and then we'll be recommencing in just a few moments with with LED vision, and we're going to join all of this good stuff up and hopefully get some blinky flashy panels. People keep texting me. I don't know whether it's love or hate. Da, da, da. Lovely, right. Okay. Cool. No worries. I've got a little fan club on, and that's great. Thank you, guys. That's much appreciated. Okay, so let's move on to the next section of the show, which is getting set up a small panel, which we're going to do. We're going to use the big boy card. We're going to use a Xlight, and we're going to get it set up and hopefully playing with FPP. by the end of the hour. But let's have a go. Let's make a bit of space on here. There we go. Wanted to learn from Uncle Xlights. So Uncle Xlights won over Panel Daddy. You've got no allegiances, Kane. I'm sorry, you're a Brit from your number. We love Uncle Xlights, but I'm sorry. Panel Daddy wins. Right. So I'm going to power up, first of all, the color light card. Now, they need 5-volt input. So we're going to give it 5 volts from our trusty Meanwell here. Just over there. I've got a couple. Now they use very little power, so you can get away with quite a thin gauge of cable. So let's just connect these up. Now you probably can't see it on here, but it's actually written on the PCB which way round your wiring needs to be. So this one's labelled up as ground, and this one is labelled up as D5V for 5 volts. So I'm going to connect my let's connect my red to my 5 volts, and there we go. There we go. That's my power sorted out. I'm just going to bring that back to this power board. Now, a question that came up in one of the Facebook groups this morning, and I hadn't really thought about it until now, was should we fuse the AC side? And I thought, well, that's a very odd question, because in the UK, all AC is fused by design. And I realised that you guys in the US don't sometimes. All of our power plugs here in the UK, if we just take the lid off of this one, we can take our power plugs apart, you see, and inside they have a fuse. And that's the same for all UK plugs, whether they're moulded ones, in which case there'd be a recess underneath, or ones you can take the lid off. Every UK plug has a fuse in it. So all the UK stuff is fused as standard. I would fuse. I think it's a good idea to fuse your AC side, because that's the side that's going to go pop in the biggest style if it's going to. And so you want to get some protection on there. Make sure you fuse for the rating that you need. So for a 320 watt power supply with 240 volts over here, so 320 divided by 240 gives us a draw of about 1.5 amps for this Meanwell on the AC side. So we're fusing for 3 amps here because it's the smallest fuse we can get. That'll do us fine. But yeah, fuse accordingly. Don't stick a 20 amp fuse in there and then wonder why everything goes pop and the fuse doesn't actually notice. Fuse sensibly. So yes, fuse your AC side and fuse your DC side as well. So let's get this plugged in. Just double check our connections. Yeah, all good there. We're done. Yeah, all happy days. There we go. And you can just about see it on the video. The LED has lit up. Now, normally with an RSP power supply, it would be making a racket at this point because their fans are on pretty much all the time. But I didn't want to get it in the way of this demonstration, so I've actually unplugged it. So if it gets a bit warm, then I might have to turn it off, but we'll see. Okay, so first thing then is connecting LED vision or the PC to the color light. So I've got an Ethernet cable here that is plugged into the Ethernet jack on the back of my PC. The PC needs to have a gigabit Ethernet port for it to work. Now it can, if your PC is a bit old and you only got 100 meg Ethernet, you can get a USB gigabit Ethernet port, and that will normally do the job just fine. So I'm going to plug that in to the color light. There we go. It's plugged already into the PC. What size fuse on the DC side? Sorry, I've only just caught that. You need to fuse for the size, the number of panels that you're running. So I've got 5 amp fuses in here at the moment. I think they're 5 amps. Yeah. So that'll happily run a couple of panels, a couple of indoor panels, because they use about 2.5 amps each. Do you sell meanwhile breakouts? Yes, they are most definitely on my site. Yes, Kane. Yeah, exactly. So P5 indoor P5s up to 2.5 amps each. 2 panels running off one of the Y connectors there gives you 5 amps. If you're running 4 of them, it's 10 amps. The outdoor panels can be up to about 6 or 7 amps each. So you just need to fuse accordingly. Right. Cheers, Dom. Much appreciated. Let's get LED vision started then and dragged across. Now, the first thing we need to think about is what size is our panel going to be? So let's get this started. Here it comes. Right. So I need to share my screen again, bear with. Share screen 2, share. There we go. Right. So LED vision 7.2. So this is as it starts up. So it's going to give us a representation of what it thinks the panel should look like. And then we've got the configuration side. Now the panel I'm going to build here is going to be a 2x2 P5. Now the P5 panels are 64 pixels wide by 32 pixels high. So what we're looking at is 64 times 2, so 128 pixels wide, and then 32 pixels high twice, so 64 in total. So we need to set LED vision, first of all, to that size. So what I'm going to do is I'm going to go into control and screen size and count settings. Here we go. And this is where we set the width and the height. So these top 2 over here, the position, they just relate to the position of this graphic. We're on -15, 22 and 74 because I'm running a dual screen PC here, and they're over on the far left hand side. So it's the width and the height we need to set. So for 2 panels wide, that was 128 for P5s. That would be 64 for P10s and a height of 64. Apply. There we go. And that's now given us a more compact screen. And that's what our panel should look like when we've finished. So I'll apply that and come out of it. And now we go into the configuration side. Now, what I'm going to do is I've gone off slightly wonky here. We need to, I need to stop sharing for a moment and then stop share. There we go. Right. So what we need to do first of all is to actually get the panel ready. I've gone off, got all excited with LED vision, having talked about it on the screen and then not actually thought about what I've got to do. So let's get 4 panels. 2, 3, and 4. There we go. So there's our 4 panels. Make sure the arrows are all pointing in the right direction. So they're all pointing up. And then we'll just quickly put some brackets on to join them all together. Now, if I was a good Blue Peter person, I'd have one prepared earlier, but I wanted to do it on the fly to show you how it all worked. Now, just be a little bit careful if you're buying brackets for panels. There are at least 2 different spacings on the mountings for P5 indoors. So that is P5 indoors. There are at least 2 different positions for the mountings. They're very close together. One is only a couple of millimeters out from the other one. It's enough to mean if you get the wrong sort of brackets, they won't fit. Now, of course, panels for us, brackets are universal, which is why they've got slightly funny shapes, because they will fit either. I'll be honest, when I first got a batch of panels with the different spacing on them, they came from the same vendor with exactly the same LEDs on the front, but they used a different supplier for the frames, and they were different. So yeah, a sudden bit of retooling. Fortunately, we didn't have to any of these injection molded or anything like that. Otherwise, we'd have been in the whatnots. It was just a late night on the CAD, and we were ready to go again. There we go. And it's all coming together. There we go. We're almost there. I won't stick any on the edge, on the short sides, just for time, but so these brackets will fit either there on the sides, there or there, or on the bottom. There we go. And one more. Right. So that's how panels join together. Now we need to do power and data. So I'll do data first. Now we've got J-ins are on this side over here. So we're going to jump out of J out into J in, and same again, J out to J in, and then we need to do power, which is, there we go. So I'm going to do this side with one, and then we have a pair of tails to go across. Now I should turn the power off at this point, because I'll be a good boy. Look at that. I generally don't get upset if you do them live, but it will be typical on a demo like this that they decided to let the magic smoke out. And as you all know, once the magic smoke is out, you can't put it back. Oh, that's that one. And then 1, 2. And into 1. And 2. There we go. So that's our panels dated and powered. Now I'm going to use these rather, I've got some rather long cables which I'm going to use for the data in, just to make it easy so that you can see. So this is going to be the top row of my P5. So this cable going into the data in on the beginning is going to go to output number 1 on the color light. So these are, you can't see it from there. So these are labeled 1 to 4 and then 5 to 8. So the top row needs to go to port number 1. So port top into 1, and then the second row is going to go into, you'd have to make your own power cables. You'd have to cut and shut your own cables, Randy. They come as Y cables. Any bigger than that, you'll have to concoct your own. Get your solder seals out or whatever. There we go. Row 2 has gone on to output 2. Row 1 onto output 1. And I can then flip this over. There we go. So hopefully, yeah, it's just about big enough to get it all on the screen. Okay. Sort of ish. Right, so back to LED vision. Power, first of all. Let's get power connected back up. There we go. And we've got a red LED on the color light now. And there is some flickery nonsense going on here. It's not doing anything sensible yet. So let me share my screen. Share screen 2, do it. Here we go. So at this point, it's supposed to be displaying what is in this box over here up on the left-hand side. But as we can see, the color light is not configured yet. And so therefore, it's not doing what we want. Now, we've already gone in and set the screen size and count settings. So we now need to go into the LED screen settings to get this side configured. Now there is an admin password for this, and it is 168. That is 168. So I'll just put that in. There we go. And it's thinking about it. Okay, so it's complaining that it can't talk to the color light for some reason. So let's have a quick look. There we go. It's giving me a window over here. Right. So that is helpful. Let me set that to there. Oh, it's talking to it now. Okay, marvelous. Technology is grand. So yeah, so if you've got more than one network card, then you need to specify it here. I've got 2 at the moment. I've got the PC is connected hardwired to the network, so I can get this presentation out in one piece. And then the second one is running to the color light. The sending device at the top needs to be set to net card, and then you set your Ethernet, press detect, and it should find your card. And it has, and it all is good. So that's good. So we can move on then straight away to the second tab in LED Vision, which is receiver parameters. Now this is where we tell it exactly what's going on, and we configure the card. So once again, we need to tell it the width and the height of the cabinet. And then if we have to, we can go down into this section at the bottom, but I'm hoping not to. Now, the reason for that is because it's a bit of a pain to set up. And if we've got an RCBVP file from our vendor, then we don't need to touch this. So we have got one of those files. So I'm going to go down to load at the bottom. And don't worry, I know I haven't configured this yet, but you'll see why. I'm going to go to browse, and it thinks about it again for a moment. There we go. And it's going to ask me where the file is. So Here's one I prepared earlier. I can open that up. And you see it actually just changed the numbers in here for me to the maximums that are available with this configuration. So the maximums available with this configuration are a width of 512, which equates to 8 panels with P5s, and a height of 256, which equates to 8 panels. Now, because we haven't got that, we've got 128 pixels wide. We can set that in here now. And our height is 64. So we can set that. And that is all we need to do, ready to push this side of the config to the card. Now, as long as you've got those files, really nice and easy. So I'm going to save that to receiver. And that's part one of the configuration. There are 2 parts to it that you need to do, and you need to push both halves. Oh, there we go. That suddenly woke up. You need to push both halves of the config to the color light. Otherwise, when you turn it off and on again, it will get amnesia and you'll need to configure it all over again. So we've done this page. The second tab is the receiver mapping tab. Now, this is where if you had 2 color lights, you'd set the 2 up, but we've only got the 1, so we need to set that up here. Once again, we need to set the width and the height. It's got the width right. We need to set our height. So we'll set 64 in there. So I've just clicked on it, configured it over on the right-hand side here, and then clicked off. And then I can push that to the receiver card as well. So there we go. LED vision is apparently frightful, but we've done it already. So our config for LED vision is now complete. And there we go, that's done. We can now confirm it. Oh, I just clicked off it. We can confirm, where is it? Where have you gone? There you are. If I drag my mouse across the screen on screen, we also drag the mouse across the screen on the panel as well. So we can see that that's working. Now, there was reference earlier, I'm running a little bit behind time, so I'm not going to dwell on it. There was reference earlier to displaying other things on a panel, and you can do that in this section on the left-hand side here. If we expand this LED 1 with a normal page, and then expand it again, we can get a file window. There we go, and that started building a file window for us, which we can expand to the whole thing. And then if we expand the file window again with another add, we can add a video. And I've conveniently got some suitable footage ready, which you'll see in just a moment. Here it comes. Hey. There we go. So we've got TV on our panels. Right, thank you for that. So yeah, so there you go. That's as easy as it is to set up a video. And once you've got it configured, you can just hit the play button at the top and it will play without the borders. I'll just hit play. There we go, away it goes. Yeah, thanks, Santa. There we are. So that's how you would run a video out through LED vision. So that's LED vision is done. The card is now configured and we're ready to unplug it from the PC and take it back to Xlights. Why didn't you need to tell LED Vision to use the 2 ports for the 2 rows? How did the card know the layout? Yeah, it's very clever, because the receiver configuration file knows the sizes of the panels, because the receiver file is unique to the panels, not to the receiver card. So the receiver file knows the panels are 64 wide by 32 high. So we told it we got 64 and 128. So it's worked out it's 2 by 2. So we didn't need to do it. It's just done it. Really simple. No messing there at all. FPP is a bit more difficult, and we'll show that in just a second. So I'm done in there. Let's come out of there. Program. No, I don't want to save the program. So if it asks you to save the program, it's just this configuration-y bit in LED Vision. We're not interested in that because we were just sorting out the card. Right. So I'm going to unplug the cable now from the PC. There we go. Brand new cable. It's a bit stiff. Right. Let's move this up a bit. I'm now going to bring my Pi into play. There we go. So I'm going to be using the Pi 4 that we showed off earlier, but I've got an SD card in there already. I'm not going to go through a full install of FPP. I understand that that's happening on a presentation tomorrow, so I don't want to steal their thunder. So I've got an instance of FPP already installed on this Pi. The only things I've done to it so far is configure a static IP on the Wi-Fi. Well, I've configured the Wi-Fi with a static IP, so I didn't need to fuss about with trying to work out what its address is. Now, I'm using Wi-Fi to talk to this Pi because they've only got one Ethernet port on them, and that's going to be connecting to our color light. So it means that we can't use it for standard networking. You can, of course, get a USB Ethernet adapter, plug it into one of the USB ports on the Pi, and use that to talk back to your home network. Now, if you're using a Pi 3, then it doesn't matter whether you connect the onboard Ethernet or a USB Ethernet to your color light and one to your home. As long as they're both gigabit, then happy days. The Ethernet on the Pi 3B Plus and earlier is actually just a USB Ethernet adapter, but it's built into the board. There's no dedicated bus for it on a Pi 3 or earlier. It's just a USB interface just built onto the board, so it doesn't matter which you use. On a Pi 4, there is dedicated circuitry, a dedicated bus from the network port into the main processor. So you're going to get far better performance off the Pi 4's Ethernet, onboard Ethernet port than you would do through a USB adapter. So if you're using a Pi 4, always use the onboard for a color light for your best performance. Doesn't matter if it's a bit slower, talking back to your home network if you've got a USB Ethernet adapter on there, because time is not of the essence at that point. So I've got my Ethernet cable. I'm just going to plug it into one of the ports on the color light. Doesn't matter which, by the way, they're interchangeable. Just pick a port and plug it in. And if you're using the second color light, you've got a spare one there for that. So then, this is going to go into there. And there we go, happy days. So all plugged up. Let's now get I've got too many windows. Hiding under here somewhere is here it is. Right, we don't want that. Let's come out there and we'll go into here. So the IP address that I've put on my Pi is 101. Hey, there we go, it worked. Right, so this is my Falcon Pi player. All I've configured so far is the networking, and I expanded the disk to get rid of the nasty red line across the top. I haven't configured anything else yet. So let's go ahead and look at that now. Wow, we're halfway through and I'm running well behind. I don't know whether we'll get to Xlights, but we'll see. So input output setup, channel outputs. Okay, so this is where we set up our outputs. So we're going to go to the LED panels tab. And this is where we set up our panels. So we need to tell it, I'm going to leave the output disabled first of all, because we're just configuring. So we don't really want it chucking stuff out yet. So we need to configure our panel layout. So our width is going to be 2. Our height is going to be 2. We can ignore the nicely red line at the top for the moment because we're still going. We're going to change more things before we've finished. So we've got width of 2. So we've got 2 panels wide. We've got 2 panels high. Our panel size. Now, what sort of panels have we got? Now, P10s are 32 by 16. And depending on whether they're indoor or outdoor, it depends on the scan rate. You could have a 32 by 32 16th scan square panel, which is basically half of a standard P5, or we can have a standard P5. Now these are indoor panels and they are 1/16th scan. Now, if I show you on, on one of these, all of the panels, whether they're indoor or outdoor, will have a line of text somewhere in the middle of them telling you the scan rate. Now, on these particular P5s, the scan rate is hidden conveniently right underneath the middle of this center bracket, but it actually says 16S in the middle of this text, which means they're 1/16th scan. If you were using outdoor panels, then grab an outdoor one. Buried under lots of others. Yeah, it's easier to read on this one is here. Let me try and get that into, well, you probably can't see it, but it says 8S in the middle of there for the outdoor one. So that's an 8th scan panel. There we go. So that's set for 1/16th scan. Our model start corner is top left. We're going to leave that there, but make a note of it, top left, because you will use top left in your Xlights config. Brightness will leave at 100%. Your gamma you can leave at 2.2 for now. Color depth, again, you can leave. And your connection. Now, if you're setting up a hat, a cap, or a cape, i.e. on top of a Pi or a BBB, then you can leave this be. We are going to swap it to color light. Now, there is an alternative to color light called Linsen, but that's not used very often these days. Nearly everybody's using color lights in our hobby. There we go. So that's just changed the settings slightly. The only other thing we need to change at this point is to check the interface. Now, because we only have one Ethernet port running on this Pi, there is only one Ethernet port available to us. If there had if there was a USB interface back to your home network, you would have an ETH0 and an ETH1, and you normally want to set ETH0 for your panels. Okay, so Mitchell will come back to you in a few minutes with that question. Okay, so panel layout. So we've got O's and P's and C defs. So the O's are the output number. So that is the port number on our color light card. So we've got row 1, our top row, connected to output 1. So those are correct. And we've got row 2 connected to output 2. So O2 for our bottom row. And then the P's are the panel number. Now, from the front, Our input side is on the left. So we need to make sure that our panel reflects that. Now I'll just get myself confused because I've got a panel facing one way and a monitor facing the other way. So the right-hand side is actually your input side. It's on my left at the minute because it's upside down. So panel ones are on the right-hand side, and then panel 2 is on the left. So there we go. So we've got O's and P's set. C defs relate to the color order of the panels. Now, unless you're mixing and matching panels from different vendors, these will always stay the same. You can change them on individual panels if you wish to, but we're not going to do that because they've all come from the same vendor. They're in the same batch. So that's the basic config of FPP configured. So what we need to do now is to save that. And then I'm going to enable it and save. And it's up the top, it's saying FPPD needs a restart. So we'll give FPPD a restart. Now this can take a few moments sometimes, particularly on a 3B plus or earlier. It says it's restarted, and then sometimes if you go and click on status, oh, it's actually done it today, you lose the screen because it's not quite ready for you. But don't worry, if that happens, just hit refresh and then it'll come back. So I want to go into display testing now to make sure that we are configured. So I'm going to go into status and display testing. We want to double check that we've got the right number of channels. So 24,576 channels. Now that is correct because we have 2,048 pixels on each panel. We have 4 panels, so we've got 8,192 pixels in this tiny little area here. Each pixel is made up of red, green, and blue, of course. So 8,192 times 3 gives us our 24,576. So we've got the right number of channels. So let's start by checking colors. We want to make sure that our color order is correct. Different panels from different vendors sometimes have a different color order. So we need to make sure that we get that set up right. And we can do that with these sliders down here. I'm going to enable test mode and let's see what it does to your lovely. Right. So you can see a lovely stripy white because the sync isn't the same as the webcam, and it's white, so we're going to get all of them because we've got all 3 sliders up to the max. If I drop green and blue back, I should get red, but I've got blue, so our colors are not right. So we've got B, we should be going for RGB, but red we're getting blue. So I'm going to make a note that instead of red, I'm getting blue. And then we'll drop that one back and we'll bring green up. Green is correct. We're getting green for green. So we can flag that as being correct. I'll drop that back, and then blue hopefully will give us red because that's the only color we haven't seen yet. Gives us red. There we go. So we know that RGB, instead of RGB, we're getting BGR for red, blue, green, and then red. So I'll drop that back out. Now we can go and fix that right away. So if I go turn test mode off, I go back into input output setup, channel outputs, LED panels, and our color order here was set to RGB. but we've just proved that it's actually BGR. So I'm going to save that there, put that there, save, restart FPPD. There we go. And then I'll go back to status display testing. There we go. We'll turn test mode back on. That's doing a chase for us at the minute, which is lovely. But what we want is a fill. And if I drag those, there we go. So red is now red. Green is still green. And blue is blue. So there we are. We've got our colors all sorted out now, which is awesome. So that's the setup side of the panel complete. So we've been through it. We set the height and the width. We set the panel type, told it where to start, and we've set it as a color light. If you were running a hat cap cape, then you're pretty much the same. You've got a couple of extra bits for the wiring pin out. 99% of the time that will be standard, and use GPIO slow down. You want to run it down to 5 if you're running a Pi 3B or 4 to make sure it all works all right. If you're running one of the Hanson MFC hats, you also need to check the CPU PWM. Otherwise, you won't get pixels and panels working together. Right, so that's that. We'll save that, restart that. So FPP is at this point ready to talk to Xlights. Now, it was mentioned, do we store MP4s or the FSEQs on the Pi, or do we just chuck data to it across the network like you would with another instance of FPP? Well, the simple answer is I would always store my files on the Pi. And that's because of the sheer volume of data that's got to get across the network, particularly if it's running on Wi-Fi. Now, for a panel this size of approximately 8,000 pixels, you're going to be looking at around a steady data stream of around 8 megabits per second to supply data for all of these pixels if you're chucking it across the network. My 8 megabits per second might not seem like much compared to a lot these days, but it's got to get there every time, on time, with no hiccups, no repeats, no anything, no problems at all. Because any issues, if you get a pack, normally with any other bits of data, if a packet doesn't get there quite right, then the end device says, I didn't get it, can you send it again? And so it just retransmits and sorts itself out. With pixel data and panel data, if that piece of information doesn't get there on time and you need to do a rebroadcast or a retransmit, then your display is going to be lagging or it's going to hiccup compared to the rest of your show. You need it to be there on time all the time. So the simplest way of doing so is to stick the files on the Pi, and then only little sync packets need to traverse across the network to say, you should be playing this sequence and you should be at this point in this sequence. And then the Pi can do it. So you've got tiny little packets saying, yeah, are you playing this sequence? Are you there? Yeah, happy days. And then 10 seconds later, right, you're still playing this sequence. You should be at this point now, and so on. Oh, thanks, mate. Yeah, we're not going to get to Xlights then, I don't think. So, yeah, I wouldn't even consider chucking your panel data across the network live. You can, of course, do it for testing, but I wouldn't do it live. Let's see if we can very rapidly crash into Xlights and do something. It's going to be very quick and very dirty, but we'll have a go. Let's get Xlight. I haven't even got Xlights open. Bum, bum, bum. Cool. Right, Xlights. Here she comes. Right, so because I'm going to use, I'm not going to use E131 for this. I'm going to use DDP. So I don't need to set up the input, output, channel input side at all, because Xlights will discover it and sort it out for itself. The only thing I need to do is to put Xlights in, FPP into bridge mode, so it's ready to talk to another device that's sending data to it. Right, Xlights, have you booted yet? Xlights is still thinking about life. It's coming up in the background. Bum, bum, bum. Yeah, I think my PC is having a go slow now, running Zoom, PowerPoint, everything else. Here it comes. Are you going to let me have it? Can I drag it over here, please? Pretty please. There it is. Right, so we've got a bare bones copy of Xlights. This one's a few versions old, but it's the same. Nothing much has changed. So all I need to do for this, to put it in as a controller, is to do a discover. And all being well, Xlights will find, there we go, it's found it. It's got a bug at this point because it says it matches an existing controller, and there isn't one. So I don't know what it thinks it's matching, but all I did was I clicked on Discover from the Controllers tab, and it's found it for us. So it's set up the controller under DDP with its IP address and the correct number of channels without us lifting a finger. It's just done it, nice and simple. So we can then go into layout and we can set a matrix up in here. Bump. Here we go. There's a matrix roughly the size of ours. Now, so horizontal for direction is correct. The number of strings is the number of rows vertically. So we're going to be going with 64. The nodes per string is the number of pixels horizontally or across. So we're 128. There we go, and that looks more like a matrix. Strands per string can stick with 1. Starting location. Now I said to make a note of that in FPP, and that is going to be top left, and that matches FPP. And I've just scroll wheeled that one. And that's all we need to change in here, really. Start channel, we can set. If we've got more than one controller, then we'll need to set this. So we can just go to the 3 dots and go find our controller. There we go. That's connected that to that. Lovely. And I can save that now. So straightforward, we've just got the height, the width, top left, and the controller that it's connected to. So that's done, and we're ready to stick a sequence on it. So if I go to sequencer, start a new sequence, I'm going to go for an animation, 20 frames per second. And it's thinking about it. Xlights not responding. Marvelous. Have you crashed on me, Xlights? No, it's just thinking about it. There it goes. Right, so in true Xlights fashion, there's only one effect that we can put on it. It's butterfly. So let's drag butterfly onto our matrix. We'll stretch it out a bit. And then if we turn on output to lights, the light bulb, we should get our pixels. So we've done it. We did manage to crash through, a bit rapid, I'm afraid. So please do go back and have a look at the recording when it's released on the YouTube. Bit of a crash course there, but it shows you that it's not as big a task and as onerous a task as people might make it out to be. We've crashed through a complete panel build from start to scratch, configured LED vision and a color light card, and got it all going in about 50 minutes. So not too shabby. So yeah, fire away with any questions. Game on. And the floor has gone quiet. How many people?
Greg,
Hello.
Could you speak to one card versus two? You might have done that before, but I was in another class.
Hello, darling. How are you?
I'm tired. How are you?
Yeah, likewise. Likewise.
I bet you should be a little more tired.
Yeah.
What were your thoughts on two cards versus one card these days?
So for version 8 color light cards, they will do 8 panels wide happily on their own at full speed. For version 7 and earlier, I would double them up for 8 panels. 8 panels, version 8's 8 panels wide. If you need more than that, get 2 cards and daisy chain them.
Oh, fantastic. It looks like I'm going to be selling a color light card.
You just if it ain't broke, don't fix it.
Well, I agree. I'm
yeah, if you've got one, yeah, don't go buying new ones just because. Yeah, if it works, happy days.
That's awesome.
How good is the Hanson little Raspberry Pi hat compared to a color light card?
It's not a patch on a color light card, but perfect for a small job. If you've just got a little tune to sign or something, then that'll work beautifully.
I've got 9 panels in my shopping cart.
You've got 9 panels in your shopping cart. What are you putting them in, as a 3x3 or? That
was the plan.
They'll be fine. A Hanson board will do that just fine. If you've got the space and you feel like going crazy, then yeah, a color light isn't much more money. If you're looking at them in my store, I haven't got any color lights at the minute. They're due in about a week, so it depends how quickly you want to play.
I brought a color light from you last year.
Oh, sorted. There we go then.
Does each color light card need its own Pi player?
Well, no, you can daisy chain 2 or 3, up to 12 panels wide with 1 instance of FPP. So FPP is the limiter there. Up to that, yes, you can daisy chain them to do whatever you need to do.
Yeah, because I just wanted to do like 4 different displays that are just like 2x2s.
How far apart would the different displays be?
Like 20 to 30 feet, let's say. It's like enter, exit, all that, just kind of more of, thanks for coming.
Yeah, no, that should be doable. You've just got to daisy chain the Ethernet cables around from one to the next.
Okay. Okay, cool.
Yeah. You'll have a little bit of fun setting it up in Xlights, but it's doable. We've done it before.
Would I just make it a 2x8 then in the scenario of 4 of them? And
exactly, and then submodel it. Yeah.
Gotcha. Okay, yeah. That seems easy enough.
Do the submodel for 2x2s, and then that'll work.
Okay, great. Thank you.
No worries. Let me stop this screen share, and then I can see you again.
Could you not also do that with the flat ribbon cable?
You could do, but it's a lot clunkier to try and drag about if you It's up to you, really. There we go. Yeah, you could drag ribbon cables about, but Ethernet's a lot easier. Thank you. Yeah.